In this video, we are going to be considering the gradients of a straight line. The gradient is the ratio of the rise to the run. So this is rise over run. The implication of this is that if I draw my y and x axis and I have a line, this line here, if I pick 2 points on this line, just any arbitrary pair of points, and call the points A and B, then we would see that starting from the point A here, the coordinates here can be obtained by tracing it to the x-axis. I'm going to call that x1, and tracing it to the y-axis. I'm going to call that y1. So we can see that the coordinate of point A is x1, y1. If I do the same thing for B, tracing it to the x-axis to obtain x2, and to the y-axis to obtain y2, thus the coordinate of B is x2, y2. Changing the x-axis is how far this line has run. So we can see that this is the change in x. So this is x2 minus x1. It started off from x1 and it has ended at x2. So the change is x2 minus x1. So this is how far the line has run. Similarly, looking at this, we would see that from point A, it started off at y1 and it's ended at y2. So right here is the change in y, and this is how far it has risen. This is y2 minus y1. Thus, the gradient is usually represented by lowercase m. Is the change in y, because the change in y is how far it has risen, divided by the change in x. And here we can see that the change in y is y2 minus y1, and the change in x is x2 minus x1. This is the formula for the gradient of a straight line. Now, the gradient is also known by another name. It's also called the slope. What this tells us is that to obtain the gradient of a straight line, we just need the pair of points, the coordinate of the pair of points, x1, y1, x2, y2. We substitute into the formula and we'll get our gradient. Let's take a few examples. Calculate the gradients of the line joining the following pair of points. So we've got 3 questions here. So we're going to solve each one in turn. The first one has points 1, 1 and 3, 5. So all we just have to do here is to label this as x1, y1, and the second point as x2, y2. And we know what the formula for gradient is. y2 minus y1 over x2 minus x1. Thus the gradient here would be y2, this is 5, minus y1, that's 1, over x2, that's 3, minus x1, that's 1. So 5 minus 1 is 4, 3 minus 1 is 2, thus the gradient is positive 2. The second one, these are the points, negative 1 half, comma 1, and 0, comma negative 1. So as usual, we know what the gradient is. y2 minus y1 over x2 minus x1. Thus, this is going to be x1, y1, and this is x2, y2. So fixing this into the formula, y2, that's negative 1, minus y1, y1 is 1 here, over x2, that's 0, minus, then x1, that's negative 1 half. So minus 1 is a minus 2, divided by 0. Negative negative is positive. So this is equal to negative 2 over 0 plus 1 half is 1 half. So the gradient here, negative 2 divided by 1 half, is just negative 2 times 2 over 1. We flip. So this is negative 4. So the third one, we've got this pair of points. So the first thing we are going to do, identify the points Then label each point x1, y1, x2, y2. So this is x1, y1, x2, y2. Thus, the gradient here would be y2 minus y1, that's 3c, minus y1, y1 is negative c, divided by x2, x2 is c, minus x1, that's 2c. So this is 3c, negative negative is positive, divided by c minus 2c is negative c, 3c plus c is 4c, divided by negative c. So here, c can just make way for c. So we've got a positive 4 here and a negative 1. Positive divided by negative is a negative, so this is negative 4. These problems tell us that gradients can be positive, as we have here, positive 2, negative, as we have it here, negative 4, and as well, the gradient of a line can also be 0. First, let's talk about the positive gradient. Since we know that the gradient is a ratio of rise over run, so a line is going to have a positive gradient if the change in y is positive and the change in x is also positive. So we have plus divided by plus. This is plus. Or a line is going to have a positive gradient if the change in y is negative and the change in x is also negative, because we know that negative divided by negative is also positive. So for example, drawing the x and y axis here, and if this is a line, if I pick an arbitrary pair of points a, b, draw to the x-axis x1, to the y-axis y1, and I do the same here, x2 and y2, I'm going to see that y2 here is greater than y1. Thus, y2 minus y1 will be positive. Similarly, x2 is to the right of x1, so x2 minus x1 would also be positive. So this line has a positive gradient. So if I also draw it on the other part of the graph, such that the change in y is negative and the change in x is negative, I'm also going to have a positive gradient. For the negative gradients, the reverse is going to be the case. Here, since the gradient, of course, is the ratio of the rise over run, and I know that I'm always going to get negative if I've got a positive at the top and a negative at the bottom, or if I have a negative at the top and a positive at the bottom. What this means is that a line is going to have a negative gradient if the change in y, that's the rise, is positive, but the change in x is negative, this is the run, or the change in y is negative and the change in x is positive. The first condition is that as this graph rises from the bottom to the top, it's going to run from the right to the left. So this is positive, negative. Or as this graph rises, this line, as it rises from the top down to the bottom, it moves from left to the right. So this is negative, positive. For example, I can just illustrate it here. If this is the y and x-axis, and my line looks like this, we would see that an arbitrary pair of points would produce, so I'm just going to call this PQ. If this is x1, this is going to be y1, and at Q, I would have x2, then y2. So clearly, x2 is greater than x1 here, but y1 is greater than y2. So it's obvious that my y2 minus y1 here would be negative, but x2 minus x1 would be positive. So this line PQ would have a negative gradient. And finally, a line is going to have a zero gradient if it's strictly horizontal. So if it looks like this, And this makes sense because if I pick an arbitrary pair of points AB and trace to the x-axis, this is x1, to the y-axis, this is y1. If I trace it as points B, this is x2, and I would see that y2 matches y1. Thus, the gradient here, which is the ratio of y2 minus y1 over x2 minus x1. So since y2 is the same as y1, so this is 0, and I have x2 minus x1. And a fraction would always be equal to 0 if the numerator is 0. So an horizontal line always produces a 0 gradient. Thank you for watching this video. If you find it useful, kindly like it by giving it a thumbs up, share it to your friends and colleagues on social media, drop a comment, and do not forget to subscribe to my channel by clicking on the subscribed icon. To get notified when I upload new videos, click on the dark bell button under the subscribed icon. Thank you once again for seeing the video.